What if you had 6 months warning that a massive asteroid was heading toward Earth? It's a scenario once confined to science fiction. But today, it's a serious question being asked in real-world science labs, mission control centers, and government briefings around the globe. Why? Because for the first time in human history, we may actually have the tools to deflect a doomsday rock and save the planet. Asteroid deflection is one of the most fascinating and critical aspects of a planetary defense. Unlike hurricanes or earthquakes, asteroid impacts are the one natural disaster we could theoretically prevent, if we act early enough. Let's break down the leading methods scientists are developing to change an asteroid's path. The most successful and tested so far is the kinetic impactor strategy. This involves crashing a spacecraft into an asteroid at high speed to slightly alter its trajectory. The change is often just a few millimeters per second, but that's enough. Over millions of kilometers, even a tiny shift in velocity can cause a miss instead of a hit. This was exactly the goal of NASA's DART mission, the Double Asteroid Redirection Test. Launched in 2021, DART deliberately collided with Dimorphos, a small moonlet orbiting the larger asteroid Didymos. On impact in 2022, it successfully altered Dimorphos's orbital period by 32 minutes. It was the first time humanity had changed the motion of a celestial body, and it proved asteroid deflection wasn't just possible, it was achievable. But DART was just the beginning. The European Space Agency's Hera mission, set to launch soon, will follow up on the DART impact site to study the crater, the ejecta, and how the asteroid responded to being hit. Together, these two missions form the world's first full-scale planetary defense experiment. Next, there's the gravity tractor concept. This method involves placing a spacecraft near an asteroid and letting their mutual gravity slowly pull the asteroid into a new trajectory. It's a gentle, slow process, but very effective, especially if the asteroid is detected decades in advance. Then there's laser ablation. By focusing high-powered lasers on the asteroid's surface, material is vaporized, creating thrust as gas escapes. Over time, this continuous push can change the asteroid's path. It's a highly precise method, but one that requires significant energy and engineering advancements. More controversial is the nuclear option. In this scenario, a nuclear device is either detonated near the asteroid to deflect it or, in extreme cases, used to fragment it into smaller pieces. While this method delivers immense energy, it raises many questions. What if the asteroid breaks into hazardous fragments? What if the detonation doesn't work as planned? The truth is, no single method is perfect. The right technique depends on the asteroid's size, composition, speed, and, most importantly, how much time we have. Time is the ultimate factor. If an asteroid is detected decades in advance, slow methods like gravity tractors or solar sails could work. But if we only have our months or weeks, faster, more forceful strategies like kinetic impacts or nukes may be our only option. This is why early detection is absolutely vital. Right now, thousands of near-Earth objects, NEOs, have been catalogued, but many more remain unknown, especially smaller ones capable of regional destruction. NASA's NEO Surveyor mission, a space-based infrared telescope, is being designed to improve detection capabilities, especially for hard-to-spot asteroids approaching from the Sun's direction. Ground-based telescopes like Pan-STARRS, Atlas, and others are constantly scanning the sky, tracking known NEOs and discovering new ones. The data they collect feeds into international databases used by scientists and policymakers worldwide. The United Nations has also recognized the importance of planetary defense. the International Asteroid Warning Network, IAWN, and the Hutsa Space Mission Planning Advisory Group, SMPK, were created to foster international cooperation and decision-making in case of an impending threat. Because in the face of a planetary-scale hazard, no single nation can act alone. But here's the challenge. It's not just about technology. It's also about political will, public awareness, and readiness. If a threatening asteroid were detected today, how quickly could humanity mobilize? Would we act in time? Would countries cooperate or compete? That's why public education, simulations, and awareness days, like International Asteroid Day, are so important. They bridge the gap between space science and everyday life, because the more the public understands the threat and the tools to stop it, the more support planetary defense will receive. At In Infinity Beyond, we believe that preparedness is power. The story of asteroid deflection is not just a tale of rockets and impacts. It's a story of responsibility, of foresight, of choosing not to be victims of the cosmos, but protectors of our only home. The sky is watching. So are we. Let's be ready.